guys, welcome to lesson 7 where we're going to talk about scatter plots. We've talked about this a little bit before, and so we're looking for when things are correlated. So that means like they're related and they have some kind of pattern. So like if you'll notice that like one has no pattern at all, if we were to draw a line with this pattern, it looks like it has a negative slope. So this is considered a negative pattern. This one is probably not strongly correlated, but there is a pattern. And so this is going to be a positive correlation. This one's a positive correlation. This one's negative, and this one does not have a correlation. So just because it has a pattern, we're looking for like a linear or an exponential pattern or something like that. And so number 6 does not cut it. Okay, for number 7, we're going to have to use Desmos for this because Desmos gives us our perfect line of best fit. Okay, so as you see here, I put all the data into Desmos, and then I'm going to go here on this button and click it, and this gives me my equation. So I'm going to round off probably to nearest hundredths. I don't really care where you round off. Something else that I want to point out is right here. This is called your correlation coefficient. So this tells you like how close, let's go back here, like in this section right here, like how close your data is together. And I think about like 0.8-ish, like that is like 80% correlated or like 88% more accurate in this case. So this is a pretty good positive correlation. So I'm going to go ahead and write this in here. Okay. And notice I like rounded up right here. Okay, if this trend continues, predict what test score you will get if you slept 10 hours. So you got to figure out, is it giving you X or Y? So hours slept, those are our X values. So this is our X. So we're going to plug this in right there for X. And when I do that, I end up with about 99.4%, and that's going to be my test score. Okay, we're going to move on, and same thing, just a different set of numbers. So if you have a situation like this, you don't worry about these numbers. Like these are the numbers that we're going to type into Desmos. Okay, so just like last time, I went here to the plus and I made my table and I typed it in, and then I'm going to go here and that's going to give me my equation. So write an equation for line of best fit. And then I'm going to round that off. And then here's my correlation coefficient down here. And again, this one is super strongly correlated. Look at that, 0.96. Like the closer it gets to 1, the closer it's going to get to like a perfect line. Okay, now that I have that in, if the trend continues, what would the water consumption be at 101 degrees? Okay, so let's see, temperature, that's going to be my X. So again, it's having you plug in 101 right here for X. And if you do, you should get about 49.7 ounces. Sorry. Okay. So now we're going to kind of switch gears away from Desmos, and we're just going to talk about if something has like, would something make like a positive slope line like this, a negative slope line, or like, is there really not a relationship between the two? So let's think about this. The hours, the number of hours a person has driven. Okay, so as that increases, does the number of miles driven also increase? And if that's true, then you're going to have a positive correlation. Okay, let's look at number 10. The number of siblings a student has and the grade they have in math class. There is no correlation there. There's no relationship. Okay, how about the age of a car? And what about the age of the car and a value of the car? Well, as the age goes up, the value of the car goes down. So it would be a negative correlation. This one I didn't really like. I didn't think it was very clear. So we're just going to ignore that for right now. Okay, the number of years a person went to school and their income. This is actually like proven to be a correlation, but it's probably a really weak correlation. So I'm going to say it's a positive correlation, but it's probably not a very strong one. Okay, now let's go down and talk about correlation versus causation. So, correlation is there is a relationship. Causation means that it causes something. So, like A causes B. So, like for instance, pressing the gas pedal causes the car to move forward. So, this would be causation. Okay, ice cream sales and sunburns, they're related, right? There's a positive correlation. I'm just going to put CORR. But ice cream sales do not cause sunburns, but sunny weather does. So that would be causation. Firefighters and fire damage, that would be correlation. Exercise and heart rate, that would be causation. And then this one we talked about in class. So some things, like there is a correlation between the number of tattoos someone has and cancer, but they haven't been able to prove it yet. So some things, like at one point it's causation, and then at another point they might move, I'm sorry, at one point it might be just correlation, but at another point it might move to causation. So if I change this to cigarettes, it's been proven that cigarettes cause cancer, so I would say causation here. But at this time, tattoos and cancer, there's only a correlation there. We can't prove causation. Okay, the next one, we're going to kind of do a shift here. We're going to talk about measurements. So you need to find like the appropriate measurement for things. And like sometimes this is more like an adult math. So if you have like feet and you've measured in feet and you go to Home Depot and the thing that you want is in meters, like how do you deal with that? And so anyway, so the first thing I would do is I would just figure out, okay, so we have 25 feet by 15 feet. And I know that 1 foot is equal to 0.3048 meters. Okay, and so rolls are sold in meters of, or rolls are sold in lengths of 5 meters. So I think what I want to do is I want to change this to meters. So what I'm going to do is I'm going to multiply each thing by, okay, so if I multiply 25 feet by the conversion rate right here, I'm going to get, let's see, 7.62 meters. And then if I multiply 15 feet by the conversion, I get 4.572 meters. So this isn't a case where I multiply them together because I just want this outside here. So this is a perimeter case. So if this is 4.572, this is 0.4572. And then this is 0.762. So what I'm going to do is I'm going to add them all up together. And I end up getting 24.384 meters. So let's think about this. So if they're in lengths of, if each roll is in lengths of 5 meters, I'm going to divide this by 5. So this is about, I'm going to move this up to like 25. So 25 divided by 5, I'm going to need 5. Okay, number 2, we have this juice bottle. So I have all these juice bottles, and I have this big 5-gallon container of juice. And what I'm trying to do is I'm trying to pour the juice in the juice bottles. So I need to figure out like how many bottles I need to prepare in order to like get rid of all the juice in the 5-gallon container. So it tells me that 1 gallon is equal to 128 ounces. Okay, so if I have 5 gallons, I'm going to multiply that by 5, and I get 640 ounces. Okay, so I'm going to take 640 ounces and I'm going to divide that by the number of ounces in the bottle. So I'm going to take 640 divided by 12, and that's going to give me the number of bottles I need. So I need about 53.33333 bottles. And so it says how many full bottles of juice can be filled. So that would be 53. Okay, let's go down to this one. So a teacher wants to cover a rectangular classroom with carpet tile. So I'm thinking area in this case, not perimeter. So it's 30 feet long by 24. feet wide. And again, the carpet is sold in square meters. So its square foot is equal to 0.0929 square meters. Okay, what is the minimum number of tiles the teacher needs to cover the entire floor? So again, like I did last time, I'm going to multiply each of these by the number of meters. Actually, I'm going to change my mind on that. I'm not going to do that because it's in squared, it's in squared meters. So what I'm going to do is I'm going to actually multiply these together and get the area. So I'm going to say 30 times 24, and I get 720 feet squared. And so if I'm multiplying that by 720, I'm going to multiply that times 720. And I get 66.888 square meters. Okay, so if each meter is like each little square is 1 meter squared, then I need about 67 squares. So let's see, or 67 tiles. Okay, number 4, there's not a lot of math going on here. So what's happening for number 4 is that like we're just trying to figure out which unit does it need. So I have an aquarium, and I'm filling up this aquarium. So think about that, like it's 3-dimensional, like I'm filling up all the sides. So up here, this was like a flat surface that I covered. So it's not going to be like square feet or square inches. It's going to be down here, cubic feet or cubic inches. And since the unit that they used is in inches, I'm going to choose cubic inches here. Okay, number 5, kind of the same type of problem. So we have this space that is 100 yards by 60 yards, and then which unit would be appropriate to determine how much turf needs to be ordered. So turf, we're going to cover this space, so that's going to be square. So either square yards or square inches. And again, since our units are in yards, we're going to say square yards. Okay, and then finally, number 6, a carpenter is, okay, so I have this painting, and then a carpenter is going to build a frame around it. So think about like, we're going to have like a stick here, a stick here, a stick here, a stick here that he's going to like staple together. So we're not covering the frame. So covering would be square, and we definitely don't need cubic. And so in this case, it would just be centimeters. Okay, that's it, guys.